Math 265A. Cuesta College, I'm Joe Vasta, and today we are covering section 3.4, the product and quotient rules. So, if we're taking the derivative of a product, is it the product of the derivatives? Is it f prime times g prime? And same with the quotient. And the answer is no. It's going to be a little bit more complicated. So we're going to do a derivation of the product rule and see what it is. So we're going to take the derivative of f of x times g of x, that's a product, and we are going to use this definition of the derivative, the one that has the difference quotient. Now our function isn't just x now, or f of x, it is f of x g of x. So let's plug this into the definition, and there it is. This part right here where it says f of x plus h times g of x plus h, that's that first part. And then we have minus the function, which is a product, all over h. Okay, so what I'm going to do now is kind of a strange step. I am just subtracting f of x plus h times g of x, and then I'm adding it, f of x plus h g of x. And there's going to be a reason I do that, but it's legal. I can do that. It's like going minus 7 plus 7. Okay. So now what I did in this step is I factored out an f of x plus h out of these first two terms up here on the top. And the second two terms on the top, they each have a g of x in common, so I factored one of those out. We break this up into two fractions with the f of x plus h out here and the g of x right there. Now we know that the limit of a sum is the sum of the limits, and the limit of a product is the product of the limits, and that's what we have here. So h is going to 0 for there and there and there and there. And this one, if h goes to 0, I'm just going to get f of x. This guy right here is the derivative of g, and then we have the limit as h approaches 0 of g of x, which is just g of x because there's no h in there. And then this right here is the derivative of f. So this is called the product rule for derivatives. And it looks like this. The derivative of f times g is f prime g plus f g prime. This is called the product rule. So we're going to do a few examples of the product rule, and then we'll come back to another PowerPoint derivation of the quotient rule. We've derived the product rule where you have fg prime, it's f prime g plus fg prime. Some books write it in the other order, but I'll go ahead and do it in this order. And what we're going to do is we're going to do a few examples using the product rule. Okay, so what I'm going to do over here is I will write the product rule. Should have written it on this piece of paper before we start it. Okay. So there it is. Find and simplify the derivative. So what I have here, and I know this is called f, but we could call this something else if you want. I have my first function right there, and perhaps we should call it something else. Maybe we can call this h, just so it won't be confusing here at the beginning. This one right here we'll say is f. This one right here is g. Okay, so the derivative is the following. You take the derivative of the first, which is 2x plus 3, times the second, 5x plus 2. We put a plus sign, And then we say this is plus the first times the derivative of the second, which is 5x plus 2. So we're going to take the derivative of that, which is 5. The rest of this problem is simplifying algebra. So I'm going to do a FOIL right here. First, outside, inside, last, and then I'll multiply the 5, distribute the 5. So I have 5x squared plus 15x plus 5. I'm going to go ahead and combine like terms. So it looks like my x squareds are 15 x squared. My x's, I have 19 there. 19 plus 15, I believe, is 34. And then, let's see, my numbers are 11. The constant is 11. So this right here is the derivative of my function, which I relabeled h just for this first problem. The other ones we'll just keep them function f, and I'm going to refer to f and g as the first function and the second function. Now before I move on to the next problem, I'm going to redo this problem. Now I cannot always do this, but I'm going to do it on this just to verify that the product rule is legitimate. We did a proof of it, and some of you are not too fond of the proofs, so let's take a look at this. We could have, with h of x, multiplied that all out. Now this is not a FOIL because you need a binomial times a binomial to have a FOIL. This is more of, there's 3 terms there, 2 terms there, so there's 6 handshakes. I'm going to multiply everything by x squared, so this is 5x cubed plus 2x squared. Then I'm going to multiply everything over here by 3x, so this is 15x squared plus 6x, and then multiply everything by a 1. Okay, so this is h of x. This is not the derivative yet. So I have 5x cubed, and my x squareds are 17. 11x, and then this is plus 2. So now I'm going to go ahead and take the derivative. The derivative is 15x squared plus 2 times 17, that's 34x plus 11 plus 0. And so there's the work when you multiply it all out. So some of you might be thinking to yourself, well, I like that way better than the first way using the product rule. It gave me the same answer, so let's take a look at that. The same answer. But you cannot always multiply out like we did here. You can't always multiply this out. And you'll see that on the next few examples. So it's worth knowing this product rule, because if you're taking a class that has calculus, chances are the product rule will pop up again and again. Let's go ahead and do the next problem. And some of you might want to pause the video to see if you can do this problem. There it is, problem number 2. Your function is x cubed times e to the x. Okay, let's go ahead and take the derivative. So, I'll kind of partition this off. Here's the first function, and here's the second function. Okay, so I'm going to do a lot of this verbally. I'm not going to write down the product rule. You can have it written down on a piece of paper and follow me if you want. I'm going to take the derivative. So this is one, we can't multiply this out and do what we did in the last problem for the second method. We have to use the product rule, which says the derivative of the first, which is 3x squared, I'll put parentheses around these things, times the second, plus the first, x cubed, times the derivative of the second, which is e to the x.
And so, kind of wishing I didn't put the parentheses, because that's pretty much my answer. Look at this, is 3x squared e to the x plus x cubed e to the x. There's the derivative using the product rule. Now your book might say, hey, let's factor something out, and they might factor out an x squared e to the x, and so you would end up getting just a 3 plus x in there. And so both answers are acceptable. I know some of you would say, well, why would you do that? Well, if you did factor it out and you were like writing this up in a technical journal or something like that, there's actually more efficiency here. You didn't have to write the e to the x 2 times. So factoring things out sometimes makes it look a little prettier, but both are acceptable. Let's go ahead and do another problem that involves the product rule. So here is problem number 3, and you might want to pause the video and see if you can do this problem on your own. Okay, so what I'm going to do is I'm going to rewrite this function and write this so it says x to the 1/2 power. And on the inside I have 3e to the x minus x. So there's actually 2 ways we could approach this derivative. One way is just to say this is the first function, that's the second function, and do it that way. The other way is to multiply through x to the 1/2. You'll still have to do a product rule there, but not over there. So you'll still have to do product rule. You can't get out of it. So I'm going to do the first approach, where I say here's the first function, and there's the second function. F prime is, okay, so here's the product rule, here's the little song and dance. The derivative of the first, so that's 1/2 x to the negative 1/2 power. The derivative of the first times the second, plus the first, now I just write that the way it is, times the derivative of the second. The derivative of this guy is 3e to the x, and then the derivative of negative x is minus 1. Okay, so let's go ahead and simplify this. The first thing I'm going to do, there's a few ways of looking at this. I'm going to bring this x to the negative 1/2 downstairs, so it says 1/2 x to the 1/2. And then I have 3e to the x minus x. And I don't know why I put an equal sign. There it is. It's gone now. There's no proof of it, except the fact that it looks a little weird there. Let me just write this out here. So you'll find that maybe after you get the product rule down, the worst part could be some algebra. So what do I have here? I have 3e to the x all over 2 x to the 1/2 power. And then over here I have minus x on the top. Let me just write this down because I think I don't want to skip too many steps. And then we have plus 3 x to the 1/2 e to the x, and then we have minus x to the 1/2 power. Okay, so I'm going to change some of these 1/2 powers to the square roots because I hate writing them, but you can keep them 1/2 powers. The first term is 3e to the x all over 2 root x. This one there's some simplifying that has to go on here. I mean, there's an x to the 1 on the top and an x to the 1/2 on the bottom, so you can subtract the exponents. And you get minus, the x is going to be on the top, so it's going to be x to the 1/2 on the top, or just this. And then we have plus 3 square root of x, e to the x, minus root x. Okay, before we box that answer, we have to ask ourselves, are there any like terms there? And there are, right there and right there. And so, let's go ahead and combine those like terms. See, the deal is there's like negative 1/2 here and negative 1 there. Okay? So negative 1/2 minus 1 is negative 3/2. So I'll remember that when I get to that. So let me write out this. We have 3e to the x all over 2 root x. And I'll write this one next. Plus 3. I'll put the e to the x. This is just a matter of style. I just don't want it trying to crawl under that square root. Okay, so I have that. And then those guys, that's minus 3/2 root x. And I'll just leave the root x on the top there. So this guy right here is the derivative of our original function. So this is f prime of x. So that was one way of doing this problem. The other way, so I'll put an A by this. I'm actually going to go do the problem the other way. So some of you may want to skip forward past this problem, okay? So the other way of doing the problem, I'll do it in blue. F of x equals, I'll multiply that through. So this is going to be 3x to the 1/2 e to the x minus x to the 3/2. So let's see which way works better. Okay, the derivative. So here's the product rule right here where there's the first function times the second function. The derivative of the first, so the 1/2 jumps down and now it's 3/2, x to the negative 1/2. That's the derivative of the first, times the second, plus the first times the derivative of the second. Now I'm going to go ahead and take the derivative of this guy right here, which does not require a product rule. I'm going to say this is minus, the 3/2 jumps down, this is the power rule, x to the 1/2 power. I'm going to go ahead and switch everything to square roots. This guy's going to come downstairs, so I have 3e to the x all over 2 root x. This one is 3, I'll just write the e to the x first, square root of x. And then this one is minus 3, that's the square root of x all over 2. So look at this. Oops, I can't even box my answers. What have they been putting in my water? Look at that. It's the same as the top one. So maybe I like the second way better. I mean, when I multiplied it through, the product rule wasn't as traumatic, and I ended up getting exactly the same answer. So, for those people who skipped ahead, oh well, shouldn't have said that. So before we get to problem number 4 is going to be a quotient rule. And so we wonder, what is the quotient rule going to be? Is it going to be the same thing, the derivative of the top divided by the bottom? I mean, so we're going to do a derivation using the definition of the derivative on PowerPoint, and then we'll come back and do some more problems. Okay, so here is the derivation of the quotient rule. This is just the definition of the derivative.
the limit as h approaches 0, and there's dq. Now our function is not f of x, now our function is f of x over g of x. So we're going to plug that into the definition of the derivative, and that's what we get. There's the limit. Here's when x plus h is plugged into this function here, and then minus the function all over h. So what are we going to do? Well, what we want to do is we want to get a common denominator. So on the top, I'm going to multiply top and bottom of this fraction by g of x, and top and bottom of this fraction here by g of x plus h. And so I did that, and I end up getting this big mess here. I have an h over 1 on the bottom. I'm going to do a copy dot flip, and now the h is right there. So that's the only thing I did was copy dot flip. Now I'm going to break up this fraction into a product of two fractions. And so I'm just going to have to show you what I do here. I write 1 over g of x times g of x plus h. And then here's the rest of the stuff right here, and there's the multiplication sign. So that's what I do next. The next thing that I want to do is I want to realize that the limit of a product is the product of the limits. And so I have that right there. So we don't have any more room on this PowerPoint slide here, so I'm going to go to the next PowerPoint slide. Okay, so this is what I had written last time. What I'm going to do is I'm going to take the limit as h approaches 0 on this, and I'm going to have g of x times g of x on the bottom, and that's going to give me g of x squared. And I didn't touch the other part. Now the other part, what am I going to do? I'm going to kind of do what I did before, where I subtract f of x g of x. And when I said what I did before, what I did on the proof of the product rule. I subtract an f of x g of x, and I add an f of x g of x. Okay. Now these aren't obvious things. It's not like, oh yeah, that was obvious, I should have done that. I mean, it's clever. I didn't come up with this. And so it was kind of like subtracting a 7 and adding a 7. It didn't do anything to the expression. But now these two terms have something in common. They have a g of x, which I'll factor out. And then these two terms have an f of x, which I'll factor out. So that's what I'll do now. So there's that g, there's the f. And so we have that. I'm going to rearrange these two terms here, because I don't like to have this negative g right there. And so they're rearranged. Again, that's how it looks. So we've run out of room on this slide. On the next slide, I'm going to have this part right here written down, the part that I'm circling, that part written down. Okay, so there it is. Now what I want to do is I want to break this into two fractions, which I do. Okay. And then I realize that the limit of a difference is the difference of the limit, and the limit of a product is the product of the limits. And I have that right there. The limit as h approaches 0 of g of x is just g of x. And same with this guy right here. It's just f of x. This right here is the definition of the derivative. This is the definition of the derivative. So we end up, we're going to write f prime right there, and then this guy is the definition of the derivative of g, so we're going to write g prime for that one. So we have that right there, and let's just clean it up and make it look pretty. And we rearrange the order here, so the derivative of f over g is the derivative of the top times the bottom minus, so the product rule had a plus, the quotient rule has a minus the top times the derivative of the bottom, all over the bottom squared. So it's a lot more complicated than the product rule. This is called the quotient rule, and we should get back to the piece of paper.
So we've just derived the quotient rule. There it is right there. Now I like to see the similarities. Look at the similarities. It says f prime g, and then fg prime, fg prime. This one has a plus, this one has a minus, but this one also has divided by g squared. It is what it is. This is what the definition of the derivative gives us, whether you like it or not. So let's go ahead and do a problem. H of x is this expression here. So we have the top right here, which I'm going to call f, and the bottom, which I'm going to call g. And in future problems I will not label them that way, I'll just call it the top and the bottom. So I'm going to follow this quotient rule to try to find h prime of x. Okay, the derivative of the top, which is 4x cubed plus 10x plus 1, that is the derivative of the top, times the bottom. Okay, so I've just reached this part of the formula. Now the next thing is a minus sign. Minus the top times the derivative of the bottom. So there's the derivative, g prime. The derivative of the bottom is 2x. This is all over the bottom squared. Okay, so I'm going to distribute the x squared. This is going to be 4x to the 5th plus 10x cubed plus x squared. I'm going to go ahead and I'll take an extra step so I don't lose people. Excuse me. So this is minus 2x. X to the 4th plus 5x squared plus x. Now the bottom says x to the 4th. Okay. So on the top, I'm going to keep the first three terms the way they are. And I'm going to distribute the negative 2x. So this is minus 2x to the 5th minus 10x cubed minus 2x squared. This is all over x to the 4th. Gonna need to get another piece of paper for this one. Gonna combine like terms on the top. So I have a 4x to the 5th and a negative 2x to the 5th, which gives me, do I have any more x to the 5ths? I don't think I do. Okay, so this is 2x to the 5th. Those guys are out of there. And then I have, I don't know why I'm going so slow right now, minus x squared. This is all over x to the 4th. Okay, so there we have that. I can factor out an x squared out of the top. So I have x squared. This is 2x cubed minus 1. This is all over x to the 4th. And so this x squared is going to cancel, and this x to the 4th is going to become x squared. So I have 2x cubed minus 1 all over x squared. You could split the fraction and write it as 2x cubed over x squared minus 1 over x squared, And then you could write your answer as 2x minus 1 over x squared. So both are acceptable. And that's the quotient rule. Now, I kind of come up with a problem that, this one right here, kind of come up with a problem where we could have just split the fraction at the beginning, and I'm going to see if we get the same answer without using the quotient rule. So I'm going to bend this paper, fold it, and say, here's another way of doing this. So I'll just put part 2. So we're just going to get the same answer, I hope. So h of x is, split the fraction from the beginning, x to the 4th all over x squared plus 5x squared over x squared plus x over x squared. So the first one is x squared. The next one is plus 5. And the third one is 1 over x. But because I know I'm going to be shooting these guys with the derivative gun, I better rewrite that 1 over x. So it's x to the negative 1. Cross the line, change the sign of that exponent. H prime of x is 2x plus 0, and then we have minus 1 in front of this, so we have minus x raised to the negative 2 power. So this is 2x minus 1 over x squared. Now that way was a lot easier, and if you can split the fraction, that's great. But a lot of the examples we're going to do after that, you cannot split the fraction and you are forced to do the quotient rule. Was that the same answer that we got before? I sure hope so. It is 2x minus 1 over x squared. And for this, let's say this is the first way we did it. So we're going to continue to do the quotient rule. Let's go ahead and do problem number 5. So in problem number 5, you cannot split the fraction. You've got x squared on the top and x cubed plus 2x plus 1 on the bottom. I'm not going to write the quotient rule up now. I'm just going to circle this one and call that the top. Circle this one and call it the bottom. If you need the quotient rule, write it on a piece of paper as you're watching this. Probably the best thing you can do is do this problem on your own. Okay, the derivative of a quotient. You have the top and the bottom. So you take the derivative of the top times the bottom. You put a minus sign and you say the top times the derivative of the bottom. So this is 3x squared plus 2. This is all over the bottom squared. That is the quotient rule. So let's simplify the top. I have 2x to the 4th plus 4x squared plus 2x. Distributing the negative x squared gives us negative 3x to the 4th minus 2x squared. This is all over the bottom, BOT. That's because I'm lazy. Now I'm going to go ahead and try to get some like terms. I have, for my x to the 4ths, a negative x to the 4th. My x squareds are going to be 2x squared. And my x's, well, there's just that one term, so I have plus 2x. This is all over the bottom, which is x cubed plus 2x plus 1 squared. Now, I could factor an x out of the top, but it's not going to cancel with anything on the bottom. And I'm not going to get something that's a duplicate on the bottom. Let me just go show you. Right now I'm going to box this and say this is the answer. But sometimes there are cases where if you did factor out an x, I guess I can factor out an x, so I'd have negative x cubed plus, or yeah, just factoring that, plus 2x plus 2. And there's nothing wrong with doing this, just to check to see if anything cancels, but really that's different than that. So really this is a good enough answer. This answer also is acceptable, so I'll box it, but we could have stopped there. So that's the quotient rule. I think we should do a few more problems that require the quotient rule. What you need to do really is to practice in your homework. But to get to where you feel confident, you might want to pause the video and see if you could do the quotient rule on that example. So what I'm going to do is I'm going to say this is the top and that's the bottom. The derivative of a quotient. Okay, so I take the derivative of the top times the bottom minus the top times the derivative of the bottom. So the derivative of 1 is 0, and the derivative of e to the x is e to the x. This is all over the bottom squared. So if you're kind of going, whoa, what happened, Joe? What are you doing? I'm doing this right here. This is the quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom, bottom squared on the bottom. Okay, so let's go ahead and distribute things on the top here. Distribute this 2. So we have 2 plus 2e to the x minus 2x e to the x. This is all over 1 plus e to the x squared. It is true I can cancel it. No, I can't cancel. I can factor a 2 out of the top, but it's not going to do anything in terms of reducing the fraction. So this right here is the answer. So what we're going to do is we're going to do another problem here, problem number 7. Problem number 7 has f of x equals x to the negative 10. We're going to use the power rule on this first. So there's going to be 2 ways we do this problem. Let's use the power rule. And really, I'm doing it 2 different ways to illustrate things, but in your homework you always want to do it the simplest way if they give you a choice. So the power rule says the negative 10 comes down there and it gets replaced with 1 minus, or negative 10 minus 1, which is negative 11. And so what do we have here? We have negative 10 on the top and x to the 11th on the bottom. When we prove the power rule, we only prove the power rule for non-negative numbers, or for positive integers actually, and then we said it works for 0. So let's go ahead and do this problem using the quotient rule. So this problem could have been written like this: 1 over x to the 10th. So here's the top, which is 1, and the bottom is x to the 10th. So here's the quotient rule. F prime of x is the derivative of the top times the bottom minus the top times the derivative of the bottom, 10x to to the 9th. This is all over the bottom squared. So what do I have on the top? I have negative 10 x to the 9th all over x to the 20th. 9 of those x's are going to cancel, and you're going to have just an x to the 11th on the bottom. So this is negative 10 over x to the 11, which is the same thing. Now that's why I would just do the power rule. This is the power rule. But we never proved the power rule for negative exponents. So that is actually what I'm going to do. So for some of you who are like, yeah, I hate math, just forward the video until you get to problem number 8. But if you're kind of a math nerd at heart, you might want to watch this. So here is the proof. So I'm going to say P is a positive integer. Okay? So like 7 or 13 or something like that. And I'm going to prove the power rule for negative integers. And how am I going to do that? I'm going to say f of x equals x to the not p, but to the negative p. And then we're going to see what this gives us. We know the result. It should have negative p, x, and then raised to the negative p minus 1. We know that that should be the result. So what I'm going to do is I'm going to go ahead and write this as 1 over x to the p. And it's going to look kind of the same as the last problem, except this is a little more general. I'm doing the quotient rule. The quotient rule, we have the top, we have the bottom. And that's some weird p right there. Oh, there it is. Okay, that looks better. So the derivative of the top is 0 times the bottom minus the top times the derivative of the bottom, which is p x to the p minus 1. So you might be thinking to yourself, oh, well, we just used the thing we're trying to prove, but what I used was the power rule for positive integers, and that's what I did there. Now this is going to be all over the bottom squared. So kind of looks like part 2 on number 7, except we had a 10 instead of a p. So this is going to be negative p x to the p minus 1 power, and on the bottom we have x raised to the, you multiply those exponents when you have a power to a power, so this is x raised to the 2p. Okay, I have negative p on the top. I'm going to cross the line, change the sign. So this is, we have x to the p minus 1. And I crossed the line on this. This is going to be x to the negative 2p. So this is negative p. I don't have to write a fraction anymore. This is going to be x to the p minus 1 minus 2p. So this is negative p x to the, I'm just going to add those up now. And what do I end up getting? Negative p minus 1. So that's the result, and that's what we said we thought we might get. That jumps down and it's replaced by 1 less. So we now have this rule here, the power rule, and we've been using it with fractions and other things. So we kind of been using it before we proved all cases, that if you have the derivative of x to the n, it's n x to the n minus 1. We knew that, but now we have seen the proof for all integers. Integers being things like negative 3, negative 2, negative 1, 0, 1, 2, 3. And later on we'll prove it for all real numbers if you care about proofs. So the next problem that I'm going to do, these are kinds of problems you'll see in your homework. Find an equation of the line tangent to this graph at a equals 2. So that's an x value. They like to call their x values a equals. So you're trying to find the equation of the tangent line. Well, you want to find the slope of the tangent line. To find the slope of the tangent line, you need to find the derivative. So let's go ahead and find the derivative. This right here is a quotient. E to the x is the top, x is the bottom. Let's see if we can take the derivative. So the derivative is the derivative of the top, e to the x, times the bottom, minus the top, e to the x, times the derivative of the bottom, which is just 1. This is all over the bottom squared. So what do I have here? I'm going to factor in e to the x out of the top. It's just a matter of style. You don't have to do that. I have e to the x times x minus 1 all over x squared. So there's the slope function. It's the derivative. What are we going to plug into the derivative? We are going to plug 2 into the derivative. So sometimes when you have the notation like this, you can go like this. You can go y prime of 2 to figure out what that slope is. So this is some notation. I don't know if your book's going to use this. This is going to be e squared 2 minus 1 all over 2 squared. So that's just a 1 there. So on the top you have e squared, and then this is over 4. This right here is the slope. The point has an x value of 2. The y value is gotten by plugging 2 not into the slope function, but plugging it into the original function. So this one looks like it's e squared over 2. Ooh, what ugly coordinates. And we don't want to like press this in on the calculator and give an approximate answer. We want to keep exact answers unless they tell us to round. So I have y equals mx plus b. We know what m is, so there's a point, there's a slope. M is e squared over 4. Y equals e squared over 4x plus b. Okay, I'm going to plug the point into that. And so this is going to give me e squared over 2 equals e squared over 4 times the x value of 2 plus b. E squared over 2 equals, that 2 and the 4, they're going to reduce, and this is going to become e squared over 2 as well. I subtract an e squared over 2 on both sides of the equation, and I get b equals 0. Can that happen? It just did. So now let's go ahead and rewrite this equation. The equation of the line tangent at a equals 2 is this. Y equals e squared over 4 times x. And there's the tangent line at x equals 2. Okay, let's go ahead, and before we move on to the next problem, we'll do some visual satisfaction. 2 e squared over 2 happens to be this point. Here's the graph of e to the x over x. It goes like this, and it also goes like this. There's the point. I graphed this. I put it into a computer algebra system, and we have y equals e squared over 4 times x. It's that line right there. It goes right through the origin because the y-intercept is 0. It's tangent right at that point. So do you have to do the pictures on this? No. But for some picture people, you can see exactly what we're doing. You know, and it all comes back down to velocity, rate of change. We will see applications of derivatives if this is getting a little dry. Okay. Some of your homework problems will ask you to find the second derivative, and sometimes even the third derivative. Now, we've already found the first derivative of this, so I'm just going to say I don't want to redo it all. So from number 8, we get, and now it's called f of x instead of y, we get f prime of x equals e to the x, x minus 1, all over x squared. Okay. So this right here is the top. This here is the bottom. Now we have a choice. We could, so we have to find the second derivative. We found the first derivative in the last problem. We could just start doing the quotient rule and do it that way. Or we can multiply through by the e to the x and then do the quotient rule after that. Maybe we should do that because I think there was a time, I'll do it that way, okay? So this is e to the x, x minus e to the x. Doesn't matter which one you tackle with the quotient rule. I'm going to attack the second one. Okay, so now I'm finding f double prime. The quotient rule says the derivative of the top, which is, well, when I do the derivative of the top, I have a product rule here. This right here is a product rule. So it's a product rule within the quotient rule. So the derivative of the first times the second plus the first times the derivative of the second. Now I'm still doing the derivative of the top. So the derivative, finishing this up, we have minus e to the x. The derivative of that is minus e to the x. So that's the derivative of the top, which was traumatic because it had a product rule in there. Derivative of the top times the bottom minus the top times the derivative of the bottom, 2x. This is all over the bottom squared. So what do I have? Wow. Well, I can see right here I have an e to the x minus e to the x. Those guys are gone. So this gives me e to the x, x cubed for that whole term. And then I'll distribute a negative 2x in there. So this is going to be negative 2 e to the x, x squared. I've just multiplied this together through the negative in front of that. And then the next one's going to be positive 2 e to the x, x. This is all over the bottom, which is x to the fourth. I'm going to factor out an e to the x times x. I can do that. So this is e to the x times x. So I have x squared minus 2x plus 2. This is all over x to the fourth. These guys right here can reduce. So that will be a 1 and that will be x cubed. So this is e to the x, x squared minus 2x plus 2. This is all over x to the third. So for an extra challenge, if you're up to it, I'll call it 9.5. Find f triple prime. I'm not going to work it out here, but I will put the work within the notes. The PDF will have the work of this. So after 9, the next page will say 9.5, and it will have the derivative of that. Let's finish up 3.4. We're almost done with it. And so you'll get problems like this in your book where they don't give you what f and g are, but they say f at 7 is 5, f prime of 7 is negative 3, g of 7 is negative 6, g prime of 7 is negative 1. So, wow. How are we to do problems like this? We are to find d dx. I'm not done writing the problems actually. So we're trying to find the derivative of the product. Now here's some notation that we've never seen. We put a line and then we say x equals 7. Okay, so what does this mean? This means that you have to go f g prime of 7. So we can't find fg prime of x because we don't even know what the functions are. But what they want us to do is to use the product rule, which says the derivative of the first, that's f prime, evaluated at 7, times the second function evaluated at 7, plus, because this is the product rule, the first function evaluated at 7 times the derivative of the second function evaluated at 7. So that's what they want us to do with these problems. This problem here has something, and I didn't put it on here until now. You're going to do the same thing with the quotient. So let's see if we can finish this up. F prime of 7, negative 3. G of 7, negative 6, plus f of 7, 5, g prime of 7, negative 1. So what I have is I have 18 minus 5, which gives me 13. So maybe you can pause the video and see if you can figure out this answer for this one. This is our last problem. Okay, so what does this means what? This means f over g, its derivative evaluated at 7. That's what it means. And that still might look a little confusing, but I'm going to do the quotient rule. The quotient rule says the derivative of the top, and I'll put 7 into each of these, times the bottom, minus the top times the derivative of the bottom. Everything's evaluated at 7. This is all over the bottom squared. Okay, so I'm running out of room on this paper, and for some reason I don't want to go to another piece of paper. I don't know why. I have f prime of 7. That's negative 3. G of 7. So we've done some of these things up here, but we do have to be careful. We can't just copy that down because we need a minus sign. F of 7 is 5. G prime of 7 is negative 1. This is all over G of 7. Negative 6 squared. Okay, so on the top I have 18 plus 5, and on the bottom I have 36. 18 plus 5, last time I checked it was 23 over 36, which cannot reduce anymore. That is the answer. That completes section 3.4, product rule, quotient rule. Do your homework, have a good day, and I'll see you in the next video.